So we're going to start by going into Workbench. Now ANSYS has two fluid CFD modeling programs now. They used to just have CFX, which was their own basically made program. They developed it in-house. Fluent they purchased. Fluent was its standalone. Wasn't really under anybody else. They bought it about, I want to say 7 to 10 years ago. And so it doesn't quite have the same look as what we've done with mechanical when we did all the stress analysis, but it's still under the ANSYS heading now. So we're going to drag that in, and that's going to be our project. All right, so just drag and drop. And so you can right-click on geometry and import geometry, and if it shows up here, great. Otherwise, you just browse and go find it. And all right, so that should give you a green check there right off. And the whole green icon on the probe, if you have it look in the folder on your computer, that's because it was drawn, or at least ended up in the using ANSYS's design modeler, which is fine. We're going to see it here in a little bit because we're going to go into mesh. So you can either double click on mesh or right click and edit. But basically what we're going to do is we're going to apply the mesh to it by itself. So this is one thing again that SOLIDWORKS kind of has all in its same package. It has the meshing within itself, has the solver within itself, has the post-processor within itself. And with ANSYS, it's all in specific programs. And there's programs, if you ever go through the Mechanical Engineering magazine, if you have a subscription to it or look at it up on the coffee table in the offices, flip through there and you'll find a program, I believe it's Pointwise, and there's others too, and all they do is meshing. All their focus is giving you the tools to mesh your domain. All right, and then there's other ones that just do post-processing, such as TechPlot. All they do is they take the results from programs like Fluent and they post-process it so you can look at the nice little lines and see how the fluid's flowing. And then Fluent itself is really just a solver. All right, so you have all these distinct things that are filled, the roles are filled. All right, so as I said before, if anything we're modeling, we need to mesh. So we want to mesh where the fluid is going to be. So we want to mesh this part out here. We want to mesh this area in here. But this other part, right, that's kind of modeled as green on our part here, that's going to be the material. We actually do not want to mesh that. We actually want to suppress that so we don't worry about getting that as part of the model. All right, so what we'll do is we'll come under geometry here. We'll expand the geometry menu. And you can see if it's already broken into fluid, all right, and the solid. The solid being the green part. So we're going to right-click on solid, and we'll suppress the body there. Help, help, I'm being repressed. All right, so that's gone there. And now let's look at the under the meshing category. Do you see down here? You see the solver preference? Oh, sorry, let me just get that so you can see it there. Under solver preference, right, you can see Fluent there, that's what we're going to be using, but you also have CFX, which I talked about, and ANSYS also makes one called Polyflow, which we're not going to be dealing with here. So what it basically does is it sets up the mesh in accordance with what those programs would like to see. All right, but once we get into Fluent, it's going to be really helpful if we have some of the surfaces and different parts of our model labeled in such a way that we can easily pick them out and apply our boundary conditions. So that's what we're going to do now. So if we change our axis and see over here, I can click on my triad here. So here's the positive X. Let me go here to the negative X and just click on that so it quick spins around to that face. Go ahead and click on that face so it turns green. Everybody good there? All right. So right click on that. And then it's hard, I can't change the position of this menu all the way at the bottom, or second from the bottom, it says create name selection. If you right click on that face, all the second from the bottom is create name selection. So click on that, I'll pop this up. And that's going to be our inlet. So we'll go ahead and call that velocity. inlet. So we're actually going to apply a velocity boundary condition there in a little bit. So you can go ahead and call that velocity inlet. I right-click on the face. And then second from the bottom is name selection. Make sure you get the correct side. It looks like you're flipped around. Go ahead and click OK. You see. Yeah, cancel out right there. All right, so that was the inlet. So let's go to the other end. Let's go to the other end and get, we're going to put the pressure outlet. So now I get it to the opposite end. Click, right click, create name selection, pressure outlet. And I'm going to click OK. And let's go to the positive Z side. So clicking on the positive Z of our tryout here. All right, we're going to click on the face. And also want to make sure we get this area in here where the fluids can flow through our probe. And if I just click there, you see it can only click one or the other, so I have to hold down a control so I can get both faces there, both surfaces. Right click again, name selection. Call this just symmetry. And OK. And then one more, if we go back to our isometric view, and we can click on that surface that's on kind of the back side in the isometric view. And again, right click, name selection, and we'll call that far field. And go ahead and click OK. All right, so what we're looking at here is potentially this could be a probe that would be coming down from an aircraft and measuring the velocity that's the aircraft's traveling at. And so for an external flow analysis, you have to put the object in the flow and then make sure that the domain where you're going to mesh is far enough away, that's why this is called far field, far enough away that any of the effects of this object being in the flow are not felt by the wall. Because if somehow the wall, if the wall's too close, it's going to change what this thing would actually experience out in atmosphere where there is no walls. All right, so you have to make the wall farther enough away that it doesn't have an effect on the flow around the object within the flow. That's a lot of flow. All right, so you can check here on all your named selections over. If you go to your left side outline, expand that, you should see your velocity inlet, pressure outlet, symmetry, and far field. You can click through those if you want. See them all turn red. All right, so we'll go ahead then to our mesh. Click on the mesh and go ahead and right click, or you can see we have update and generate mesh up here. You can use either one. And we'll go ahead and generate mesh. All right, so hopefully that you can see the mesh there looks pretty good. All right, did a nice little, all right, much finer in here for the smaller geometry. Pretty fine around here where it goes around the probe, where we're going to have that high pressure gradient as it hits it. All right, so this is all saved automatically within ANSYS, so we don't have to do any saving here. Let's do actually one more thing. We'll do update here. Let's make sure we get all the stuff saved appropriately, and go ahead and close. All right, so again, we should come back here. If we don't have a green check, we got problems. We have to come back and fix that. It looks like we should be all right. Let's go ahead and save this project if you'd like. So I'll save this project as basic underscore probe underscore fluent. Again, it doesn't really matter what it is, just as long as you save it as something.